Let us begin our wonderful look at probability. So here we have some terminology. Pause the video, look at it, make sure you understand what it means, look at the example given. I'm not going to sit and read these to you when you can read it yourself. So here we go. Find the experimental probability of tossing a head if it falls heads 96 times in 200 tosses. So experimental probability, it's success over possible. So I'm going to take the number of successes, the number of heads, 96, divided by possible times 200. That would be 0.48. Probability is given as either a decimal or as a reduced fraction. For part B, rolling a 6 with a die, given that when rolled 300 times, a 6 occurred 54 times. So a success here would be considered rolling a 6. So how many successes were there? There were 54 out of 300. That is 0.16 repeating, or as a reduced fraction, 1/6. For smaller, nice fractions, like 1/6, oftentimes the preferable way to give that probability is as a fraction. It's real easy to read. You can see that 1 out of 6 times we're getting the 6 that we want. So here we have some shoe cleaners, Shine, Bright, Cleano, and No Scuff. We take a survey of 80 randomly selected people to find out what product is most prevalent. So based on the results, what's the experimental probability of a community member using Bright? So how do we find that probability? We take 22 and divide by 80 successes out of possible, and what we get here is 0.275. Cleano, probability of using Cleano. So 20 out of 80, 0.25. So the probability that somebody uses Bright over Cleano is probably going to happen. It's more likely that somebody uses Bright than it is Cleano. But part B says, would you classify this to be good, very good, good, or poor? And this is objective. There is no absolute right answer, but there are good answers and bad answers. I would consider this to be poor because we're looking at a community member, and usually communities have significantly more people than 80 in it. So I would consider this 80 to be a pretty small sample, and because it's a very small sample, we can't say that the data given to us, the probabilities calculated from it, do a good job of representing that entire population. New term, sample space. It's the set of all possible outcomes of an experiment. So if we're flipping 2 coins, I have all the different ways that can happen pictured here. We could get 2 heads. I'm going to make a list first. We could get head, head. Or we could get head, tail. Or we could get tail, head. Notice these are 2 different things as we are flipping 2 different coins. Head, tail is different than tail, head. Or we could get tail, tail. 2-dimensional grid. We create an X and Y axis. One basically for the first toss, one for the second toss. And on the first toss, or for first coin, we could have heads, or we could have tails. Second toss, second coin, We could have heads, we could have tails. And we're going to plot points just like on any coordinate plane. There are 4 outcomes. This dot represents head, head. This represents head, tail. This represents tail, head. This represents tail, tail. These points have ordered pairs, but instead of being numbers, they have H's and T's. And finally, a tree diagram. We start off at our initial point, and then our first coin has 2 possibilities, heads and then tails. So this is representing the first coin. Or in a general state, the first event happening. And then from that, we have 2 outcomes that could happen, and it could happen after each one of these. So we could have head, tail here. This is sort of like a road map. So we could follow the top branch and get head, head. Or we could follow the top branch and get head, tail. We could follow the bottom branch and get tail, head. Or we could follow the bottom branch and get tail, tail. All 3 of these are good ways of showing the entire sample space when looking at probability and events happening. So here we go. Illustrate using a tree diagram the possible outcomes when drawing 2 marbles from a bag containing several marbles, each containing red, green, and yellow. Drawing 2 marbles from a bag containing these things. So the 2 events that are happening, there are 2 picks. On the first pick, 3 things could happen. We could get red, we could get green, or we could get yellow. And now we're going to pick a second marble, so we're going to create a second event happening. And on that second event, we could get red, green, or yellow. And we have to add this second event after each possible outcome from the first event. Red, green, yellow, red, green, yellow. So looking at this tree diagram, how many possible outcomes are there? There are 9 total outcomes. There are 9 terminating branches of this tree. These trees are going to end up being real helpful when we look at probability.